Section 8.5, Using Trigonometry. Our objective is students will successfully use trigonometry to find angle measures and side measures. Trigonometry works because of similarity. For example, all 20, 70, 90 triangles are similar. This means that when you take sine of 20 degrees, the ratio of the sides will always reduce to 0.3420, no matter how big or small the triangle's sides are, because you're dividing out that scale factor. Okay, so because of this, a table was created using these ratios. It's to the right. So you don't have to memorize this, but it would be best if you printed it out and had it near your desk when you're doing your homework and stuff. Okay, so to use this table, what you're going to do, you're going to have a question such as find sine of 54 degrees. Now we don't have a triangle to look at, so we're going to come over to our trigonometric ratios table. We're going to scroll through the sine column, and then we're going to come across at 54 degrees. Okay, and where we cross horizontally with the vertical sine column, that's going to be our ratio, so 0.8090. Okay, and then if we were asked if we were asked tangent of 34 degrees, we would be looking at our tangent columns, and then we would do our 34 degrees, come across from our 34 degrees, and where the two intersect, that's our ratio, so 0.6745. Okay, you can pause the video and try for yourself cosine of 64. Okay, so you're going to take the cosine columns, you're going to find your angle of 64 degrees, go across to where it intersects the cosine highlighting, and you get 0.4384. Often students just use their fingers and they don't highlight because you're going to be reusing this table over and over and over again. One key thing that students mix up is they end up in the wrong column. So make sure if you are doing cosine that you are in the cosine column. If you're doing sine, be in one of the sine columns, etc. Okay. So with this, we also have ways of undoing. So if I give you a ratio of sides, you can find the angle. Okay, so just like adding and subtracting, there's inverses for sine, cosine, and tangent. So again, if you know the ratio of two sides, then you can figure out what type of right triangle it is you have. So the inverse of sine, we call it, the way we say it is inverse sine, but we write this, sine to the negative first. This is not an exponent. This is indicating inverse. The inverse of cosine is called inverse cosine, and it's cosine to the negative first. Again, that's really not an exponent, that's just a notation. And the inverse of tangent is called inverse tangent, and again, with that -1 indicating that it's an inverse. Okay, so we want to find the angle given that we know the ratio of sides is 0.7660. Okay, so we are going to scroll through our sine column. We're going to scroll down and keep scrolling with your finger until you get to our number, 0.7600. And then you're going to come back and you're going to say, oh, that's 50 degrees. Okay. If you're doing cosine, make sure you're in the cosine table columns. Okay. So you're going to scroll through the numbers in the cosine columns. Okay. Until you find 0.2588. And then you're going to come back and find the angle, so 75 degrees. So you're really just undoing what we did on the last slide. Okay, go ahead and try inverse tangent of 0.7813. Pause the video. Okay, so make sure that you were in the tangent column. You're going to scroll through your tangent numbers until you get 0.7813. And then go back and read the angle, so 38 degrees. So now, how does this help us when we are given triangles? So we want to find an angle. Notice this is in a right triangle. We have to be in a right triangle. And we want to find the measure of angle G. So we're going to be looking from angle G. And we have to ask ourselves, how are the numbers on our triangle related to this angle that we want? So how are 10 and 16 related to angle G? Well, 10 is opposite and 16 is adjacent because GI is our hypotenuse. Then you're going to be thinking about your SOHCAHTOA and who is opposite and adjacent, which is tangent. So you're going to write tangent of G equals 10 over 16. Okay. To undo tangent, remember it's inverse tangent. So we're going to use our inverse, but it's really important. The inverse goes in front. We never write the inverse after. Okay. So now, in order to do this, we need to divide out our fraction. And this is exactly what we were doing on the last slide. Okay, so we need the inverse tangent of 0.625. So we need our table. We're going to look in our tangent column, and look, we do not have a number that's perfect, but we have two numbers that are close. Okay, so what we're going to do when we have two numbers that our number is not exactly one of these numbers, you're going to take the two numbers that are close, you're going to average them. So you add them together. So 0.6249 plus 0.6494 gets you 1.2743. You're going to divide by 2. We get 0.63715. You should be using a calculator for this. And then in putting our numbers in order, it would have been 0.6249, our 0.6375, and then our 0.6494. Okay, so this average that we found of these two numbers is the halfway point. Okay, now we want to go back to our 0.625 and figure out where it falls between these numbers. So our 0.625 lands between here. So that means our 0.625 is closest to 0.6249. So we're going to go up to our table and go back across to get the angle that gives us 0.6249. So we have angle G is going to be 32 degrees. Okay. All right, how do we find a side? So when we find a side, we're going to be given the angle and our side is going to be a variable. So again, you're going to ask yourself, how are the sides related to the angle? Okay, and since we have the 42, it's that angle. We don't want to do this one because we don't know that number. And we don't ever want to use the right angle because we can't do SOHCAHTOA on a right angle. All right, so how are x and 18 related to 42 degrees? Well, x is opposite and 18 is the hypotenuse. So using SOHCAHTOA, opposite and hypotenuse are sine. So we're going to say sine of 42 equals opposite was our x, hypotenuse 18, so x over 18. We're going to use our table to find what the ratio is supposed to be for sine of 42. So you're going to go through your sine columns, find your angle 42, which is 0.6691. You're going to replace sine of 42 with 0.6691. And now this can be done as a proportion. Put your 0.6691 over 1 and cross multiply. So 1 times x is x, and then you have 18 times 0.6691. Okay. Using a calculator, you get 12.0438, and we're going to round all sides to 1 decimal place. So that will round to 12.0. All right, one more example. Okay. So again, our question is, how are x and 22 related to our angle of 35? And you don't need to write this question out. You're just really asking yourself in your head. You can even write it on the picture to save some space. So x is our hypotenuse and our 22 is opposite of 35. Okay. So again, SOHCAHTOA, who is opposite in hypotenuse, that's sine. So we're going to say sine of 35 equals 22 over x. We're going to use our trig ratio chart, and we're going to find sine of 35. Okay, sine of 35 is 0.5736. We're going to put that left side over 1 so that we can cross multiply. Okay, 1 times 22 is 22. 0.5736 times x. Going to divide by 0.5736. Using a calculator, we get x equals 38.35425384, and your calculator could go as far or shorter. Remember, we're rounding sides to 1 decimal place for this entire unit, so this side, x, will be 38.4 because the 5 causes the 3 to round up to a 4. Okay. Our essential question is, what is the first thing you have to ask yourself? And it is, how are the quantities related to the angle? Whether it's the angle that you are finding or the angle that you know. How are the quantities related to the angle? Your homework is 8.5 using SOHCAHTOA.